Hello and welcome to the lesson on three-dimensional trig application questions. The examples are suited for the questions you're going to see in the homework. So what's the learning goal? You can use my understanding of the primary trig ratio, sine and cosine law to solve 3D problems here. So we're looking at three-dimensional problems. Two examples that I have. What I did is I took a nice cross-section of the examples that you're going to see in the homework. So obviously finding the height of an inaccessible cliff, for example. I'm giving another trick for surveyors. What the surveyor will do, they will plant a stake at position A. They will plant a stake at position B, and they'll measure out the distance between A and B. They will then find a point that they can see, so it'll be a stone or a paint mark or something, and they will measure the angle from A to that line that they measured, or to stake B, and they're doing this with the transit, and then same thing, they'll measure the angle there. When they have the transit set up at point B, though, they're going to do an elevation shot and find a point above that stone, so they just move the transit upward, and they can measure the angle of elevation. All right, so the triangle, hey, this triangle is on water, so it's flat on the ground, water or on ground. And this triangle here, the second triangle, is vertical. Vertical to cliff. Okay, so it's standing straight up and down. So they're perpendicular to each other, these two triangles. So to find that inaccessible height, so we are looking for the inaccessible height h right here. So we're looking for that height. How are we going to find that? Well, we're going to find the base of that triangle, and we're going to do that using the triangle that's on the water, because we have lots of information here. If you know two angles, you know three angles in a triangle, so just redrawing the one that's flat on the water, 25 and 30, 25 meters. The missing angle then, theta, is 180 minus 30 minus 25. So we're going to take away 55 from that. So 125 is the angle that's missing. So I'm going to just set up, and like I said, it's arbitrary. So I have A, B, and C matching with the diagram above. So we are looking for side A. All right. To find side A on triangle 1. So I'm just numbering this for ease of reference. So this is triangle number 1. So it's sine law. I know all three angles. Nothing's right angle. So sine A over A equals sine B over B equals sine C over C. So hopefully I know full information about one thing. So sine A, so I know sine of 25 over side A. So that's what I want to find. Sine B, so sine of 30 over side B, don't know that length. Sine C, well, that's that sine of 125, and that's over the 25. Here's the reference, or the pivot ratio. Side B I don't care about, so that's just going to drop straight out of this altogether. And we end up with sine 25 over A equals sine 125 over 25. Doing the inverse reciprocal here, I'm going to flip both fractions to make it easier to solve for A. So sine 25 equals 25 over sine 125. Lots of 25s there just to make it a challenge. Multiplying both sides by sine of 25 to isolate for A. So sine 25, sine 25. Again, we do that for reciprocal purposes, or inverse purposes. Oops. So our A value, we can just go straight to a calculator. So I know that A value then, 25 times 25 sine divided by 125 sine. So I get 12.9 meters. So it's 12.9 meters across the river. So therefore, 12.9 meters across river. So now I'm going to look at the second triangle, which I'll draw up here, I guess. So this is looking at it from the side. So there's the 50 degrees. There's my cliff. I'm looking for the height, and I now know the distance of that length there, and that's the 12.9 meters. So to find h, we can use SOHCAHTOA. All right. So to find h, opposite and adjacent, so that is our tan ratio. Tan theta equals O over A. Tan 50 equals h over 12.9. Multiply both sides by 12.9. That allows us to isolate for the h. So h will equal to 12.9 multiplied by 50 tan. So we get 15.4 meters. So therefore, the cliff is approximately 15.4 meters high. So there you go. So it's just a matter of basically interpreting the diagram. That's going to be the trickiest part for you when it comes to interpretation, and just getting it correct as to what orientation each triangle is and what information you're looking for. Second example I have, I don't know if it's really a 3D problem, but it did fall in a couple of the examples, so I am going to give you an example of it. So Travis wants to determine the height of a flagpole in the courtyard. He measures the angle of elevation to the top of the pole to be 25 degrees from his current location. So here's the flagpole. Here's Travis. So he's looking up. He knows that that was 25 degrees from where he was. He moves 8 meters closer. So we're going to change Travis's color. It's now going to be in green. So he's moved closer by 8 meters. And he looks up again. And it's now at a 55 degree. Determine the height of the pole. So we want to know h. We want to know the h, that height. So we do technically have a couple of triangles here. I'm going to get rid of the Travis. He's just too distracting. So we're going to get rid of him. So we end up with a triangle that looks like this. That length is 8 meters, 25 degrees, 55 degrees. And that's a right angle. So how do we find our missing height? And that's what we're looking for right there. So we're looking for that height. So what can we find? Well, that's 25. First of all, we fix that. If that's 55 degrees, we can find that angle. So that's 180. So I'll just put theta just so you can see where it's coming from. You can just write it in on your diagram. 180 minus 55, just make sure you know where it came from. Oops, that's final answer. So I know theta. And if you know two angles, then you know a third. So I would know this one up here, which I'll call phi. So that's 180 minus 25 minus 125. So that means that's 30 degrees up top. So I now know all my angles inside. So what I can do is I could use sine law, but what's the purpose here? What do we want to do? Well, if we look at that inside triangle for 1 second, this is a right angle triangle. We're looking for that hypotenuse. We're looking for h. Well, sorry, height, not hypotenuse. We're looking for height. So that means that if we're looking for our height, if I had this length, I could solve for the third side. So I'm going to use sine law in order to calculate that missing length. So using sine law, to find the hypotenuse, I know that sine A over A equals sine B over B equals sine C over C. Subbing in the information, so I'll just arbitrarily label it A, B, and C. So sine A, so we got sine of 25 equals, I'm going to call it x. That's actually the length I want to find. Sine of B, so that's sine of 125. And I don't know that side, so we'll just call it little b for now. Sine C, that was the last angle I found, sine 30 over 8. So we found the pivot fraction. Okay, so that's the one we're going to use. I don't care what B is, so it simplifies our equation down to just the information we want. And I'm going to flip both fractions to get the unknown on top, just for ease of solving. Make sure, again, you flip both sides. Very important. I'm going to multiply both sides by sine 25. Inverse operation, right? What it does is it isolates our x value. So 8 multiplied by 25 sine divided by 30 sine. So let's call it 6.8 meters. So that missing length, the hypotenuse of that triangle, is 6.8 meters. So now I'll just redraw the triangle I'm working with at the moment. So now I'm with this triangle here, 55 degrees. I just found out that this is 6.8 through trigonometry. I'm looking for that height. Labeling the triangle. If that's my reference, I'd have opposite, hypotenuse, adjacent. So I want to know the opposite side. So that means I'm going to use sine theta equals O over H. So sine of 55 equals the height. I hate using H so many times here, just because it matches up with hypotenuse. So I'll put the word height in for the amount of calculations we have to do over the hypotenuse, which is 6.8. Don't want to confuse you guys if I can avoid it. It's kind of the whole point is not to confuse you. All right, so just make sure you have that H's that are straight, and make sure you know which H, what it represents, I guess. So, doing inverse operation, we can find that our height is equal to 6.8 times 55 sine. So we get 5.6. So therefore, the flagpole is 5.6 meters tall. And of course, that's an approximation. So again, another surveyor's trick to find inaccessible heights, and especially when you can't get close. If there was a pond in front of this flagpole, Travis could have still found the flight of the flagpole by not going in the pond. So is the last question 3D? Well, that's up for discussion or argument. Homework in the textbook, page 66, 1 to 10. Again, it's just being able to visualize in 3 space, and the diagrams help you out. So if you have any questions, you know where to get a hold of me. Make sure you mark them down so I can help you out.